Now, using this model, so the first thing I'll do is that I will simplify a bit the model. So usually when you're doing simulation, there are a lot of small details that you don't need inside your CAD model because they are not really bringing anything to your simulation, but they will complexify the analysis. Like, for example, these small holes or these fillets. So what you can do in this case is go into the geometry tab and use the simplification option. So in some other software it's called also defeaturing. So you have automatic tab and manual tab. So automatic tab, let's say I want to detect automatically the small fillets in this, the small holes, sorry. So here you see it's found 6 small holes. So I will select them and remove them like that. Now do the same with the fillet. Select and remove them. Okay. So now I got a part which is cleaner. So it requires some engineering judgment, of course. So you cannot suppress every fillet. So it depends really on what you want to see, and if you can do some tests, for example, with and without the fillets to see if there is really a difference. But in some cases it's just useless, so this is why you can suppress it. So now what I'll do is I will assign some constraint to the model. So I will pin this through these 2 big holes. So just select like that. So I can select the 4 faces in each, but there is an option here in the selection tool which is select neighboring edges. So it's very useful. Just have to click on that and you see it will all selected automatically. So I pin, and now I applied the constraint of the pin, and you see this is a symmetric model because it's cut like that in 2. So I have to apply again a symmetry condition. So for that I have to go into Advanced tab of the constraint and select the symmetry faces, and then you have to look on the small coordinate system which is here. So the symmetry plane is ZY. So I click on ZY and I click on OK, and I just define the symmetry condition. Now I have to apply the loading. So I will apply force to this face, and it will be a force in Y direction of 40,000. So it's quite huge force. And now that I get that, next step is to mesh the model. So now I'll use the 3D Auto Mesher. So there are three types of 3D Auto Mesher: default tetra and high speed tetra. So it's almost the same, but high speed is a bit higher, a bit faster. But in some cases it's not giving totally the same result. This is why we have 2. And hybrid mesher will give you a combination of hexa mesh and tetra mesh. So if you want better quality and decrease the number of nodes, hybrid mesher is very good. In this example I just use the high speed tetra. If you go in the advanced option, you see that this is very important, this one, high order element. So I will unactivate that. So if you use high order element with a mid-side node, it will divide your mesh element into an additional smaller node. So it will put 1 node additionally in the middle of each edge, and the element will be of higher order, so you'll get better accuracy. The disadvantage is that it generates more nodes and it takes more time to solve. So Okay, so I just generate my mesh, and now I go in analysis. So I define everything in my model, so I can check now in the work tree. So like I said, first you have your material that you define here. In the property window, you can review different coefficients of the material. You can even change them directly here and click on apply. You can view the properties. You can view the solid bodies and the mesh. And in the second tab, the load and burning condition, you have the force that I assigned and the boundary conditions. So if you want to modify that, you just have to do a right click, click on edit, and you can change, for example, either the face of application or the type of constraint. Same for the force. So you can change the direction, the value of the force, or where the force is applied simply by going into the work tree. Now let's create my analysis case. So I click on this button, General, and here it's very important window. You have analysis case window, so it will be give a name. And here in this tab you see all the types of analysis that you can perform in MyDyson-FX. So you have to know that the most simple type is linear static, so usually this is what we use. But if you want to go into nonlinear types of analysis, do thermal analysis, CFD analysis, or dynamic type of analysis, all that is different. So if you're interested by that, I enjoy you to look at our other webinars, because we did a lot of webinars on the other topics, and we have also some tutorials available on that. So today I'll talk simply about linear static, and it's all. So click on OK. So I generated my case, and I have to solve it. So you see the solving process in this window. So you can drag and drop like that, and you can view all the details about the analysis. So basically the time that it took to complete. So this is the world clock time, and this is the final time, let's say 3.3 seconds. If you want to change the size of the window in NFX, at any time you can drag and drop like that and put it in another position, for example. So if you prefer to have it here, you can like that change a bit your interface to fit your needs. So this is something that a lot of people don't know, but I just tell you. Okay, now let's take a look at the results. So once it's computed, you see that you have translation, von Mises stresses, and safety factor. So I double click, and now I have the result in translation. If I view the stresses, here I have a plot of the stresses and safety factor. Once you have that, you are in the post mode. So what is called the post mode is the mode in which you are checking the FEA results. So you have in the general tab the visualization option. So let's say you want to change to view like that the contours. You have the different edge types. So if you want to see the mesh, you can increase the deformation. So here it's a real deformation, so deformation is quite small. So it's deformation of 0.6 millimeter. So this is why you cannot see it, but if you increase it like that, so it's a symmetric model. So if you want to view the full model, you can use the mirror plane option. So enter 0. Okay. and it will look like the full model. Now, if you want to know the result at a specific point, you can use the probe tool. So it's very useful, for example, to know that, and using minimum and maximum option, you have like that with a probe where is your maximum and where is your minimum of stresses. So it indicates where, for example, you have to review the design of your model. Here you see you have a big stress concentration in this area. Let's view the other things. So clipping plane, so is a plane to cut your model like that. So I will cut like that the mirror. So here, edge type, no edge, okay. So you can view inside your model and drag it on the plane like that, and you have a view of what is going inside. So you can add several clipping plane, but you have a view of the stresses inside the model. And once you're finished with all that, you can just click on report, and NFX will generate automatically Word format report. So it will do some screen capture at several steps of the materials you use, of the mesh layout. So, and then it will use a template in Word format that you can customize. So if you have the format for your company, for example, you can use that, and NFX will automatically go inside and add the figures and the tables. Okay, so you can see here, you have it. So it's automatically taking the screen captures. So you can add more details if you want, but this is the basic type of report. Okay, and we have also 3D PDF. So if you want, for example, to output the result into a PDF, you can like that select your result, and NFX will generate one PDF format in which, so you have it here, in which you can rotate the model in 3D inside. So you can use it to send to the people, for example, who don't have the software, but you want to show them the model. So all type of results are stored in the different pages. So if you want, you can activate only the geometry or view the results.